Let's talk about a word you hear all the time, a word that basically runs our entire digital world. But what is it, really? We're talking about the database. Today, we're going to pull back the curtain and figure out what's actually going on inside this massively important piece of technology.
It's a totally fair question. When we think of data, we think of rows, we think of columns. Kind of sounds like a spreadsheet, right? But is that the whole story? Not even close. There's a brilliant, revolutionary idea at the very heart of what a database is, and it sets them worlds apart from a simple spreadsheet.
So, to really get why databases are such a game changer, we first have to understand the problem they were built to solve. And to do that, let's start with something that looks, well, a lot like a spreadsheet.
Okay, picture a bank keeping all its info in one single giant list. For every single account, they type in the customer's name. See what's happening here? If our customer Sue Smith has 3 different accounts, her name gets typed in 3 separate times. Now, for a tiny list, maybe that's fine. But imagine millions of accounts. It's not just clumsy, it's a disaster waiting to happen. And right here, this is where the whole spreadsheet idea just completely falls apart. Sue Smith gets married and changes her name. Now you have to go on a treasure hunt through this massive list to find and update every single place her old name appears. If you miss just one, well, your data is now wrong, it's inconsistent, your own system is telling you 2 different things about the same person. It's incredibly fragile.
So this exact problem, this mess of repeated information, led to an incredible breakthrough back in the 1970s. It was a totally new way of thinking about data, moving away from that one giant messy list and towards something way more elegant and way more powerful. It all started in 1970. A researcher at IBM, a brilliant guy named Dr. E.F. Codd, published this paper. And his idea was, profound, but also really simple. Stop thinking in long lists. Start thinking about your data as a bunch of smaller, related tables. And just like that, the relational database was born. So let's see what that actually looks like. Instead of one messy list, we make 2 clean ones. First up, we create a table that's just for customers. Each customer, like our friend Sue Smith, gets put in here exactly once. And this is the most important part. She gets her own unique customer ID. Now for table number 2, which is just for the accounts. But instead of typing Sue Smith over and over again, we just use her unique customer ID. Her name now lives in only one place, so if she changes it, you update it in that one spot. And boom, the change is instantly reflected everywhere that ID is used. That's the elegance of this whole thing. And here it is, side by side. The spreadsheet way gives you this single, bloated list filled with repeated, error-prone data. The database way gives you clean, organized, linked tables, where every single piece of information has one and only one home. It's efficient, it's reliable, and you can scale it up like crazy.
Okay, so how do these tables stay connected? What's the magic that makes this system work so perfectly? Well, it all comes down to a few really simple but powerful rules.
The first rule is a process with a kind of fancy name: normalization. But don't let the name scare you. It's just the formal term for what we just did, designing your table so that each piece of information is stored in only one place. Sue Smith's name belongs in the customer table, period. It doesn't belong anywhere else.
Now to make that work, every single row in a table needs a unique ID. We call this the primary key. The best way to think about it is like a social security number for your data. That cust ID in our customer table, that's a primary key. No 2 customers can ever have the same one. It's a unique fingerprint.
And finally, the foreign key. This is the glue. This is the invisible thread that links everything together. When we put that cust ID into the accounts table, it becomes a foreign key. It's basically a pointer that refers back to the primary key in the customer table. This is what creates that rock-solid relationship between our 2 tables.
Okay, so we've got these beautifully organized, perfectly linked tables. Awesome. But how do you ask them questions? How do you actually get information out of them? For that, you need to speak their language.
And that language is SQL, which you'll almost always hear pronounced SQL. It was actually developed at IBM right after Dr. Codd published his paper. And here's a fun little fact for you. A lot of people think it stands for Structured Query Language, but the name is officially just SQL. It's the standard, universal way we talk to relational databases.
And the real beauty of SQL is that it's not some crazy complex code. It basically reads like an English sentence. You just describe what you want. You select the columns you want to see, you tell it from which table to get them, and then you say where your conditions are met. Like, select first name, last name from the customer table where the last name is Smith. It's that straightforward. Now, you might be sitting there thinking, okay, this is neat for banks and tech companies, but why does this matter to me? Well, let's zoom all the way out, because this simple model of linked tables is running pretty much everything you do online.
This isn't just some random technical detail. The relational model is the invisible backbone, the hidden architecture supporting our entire modern world. I mean, every time you tap, click, or swipe on your phone, you are almost certainly talking to a database built on these exact ideas.
Just think about it for a second. Your social media feed? That's a posts table linked to a users table linked to a friends table. That online shopping cart? A products table linked to your customer profile. Your bank balance, your Netflix viewing history, your flight reservation. Yep, it is all powered by these clean, organized, interconnected tables. So the next time you use an app or a website, try to picture it. Picture those neat, linked tables buzzing away behind the scenes. And I'll leave you with a final thought to take with you. Now that you can see the difference, where in your own world do you see a messy spreadsheet that is just crying out to become an elegant, powerful database?